So this video is going to be looking at what is a sample space. In a nutshell, a sample space is a list of all possible outcomes you could get when you have a particular event. So if I was going to ask you the sample space for rolling a die, you would tell me the sample space for this particular question is, well, I'm going to use curly brackets, 1, 2, 3, 4, 5, 6. That would be the sample space for rolling a die. If I was going to ask you the sample space for tossing a coin, the sample space for this one would be heads or tails. Okay, so it's all relatively simple at this stage, but what happens if you have multiple events? And by multiple events, I mean, what's the example? What's the sample space you could get for tossing tossing? I do apologize. Tossing two coins. So if we toss two coins, what are the possible options we could have? Well, we could get a heads. We could get a heads, tails. Sorry, I'm going to put that in brackets. We could get a tails, heads, or we could get a tails, tails. So from here you can see that it does become a little bit more complex when we have multiple events, and what I mean by multiple events is when there are more than just one particular probabilities that we're investigating. So the event of one coin being tossed and the event of another coin being tossed. So it's really useful that when we're using multiple events that we write up a table. So this is pretty much only applicable if we have two events. You'll learn that in the next video, tree diagrams. We can use tree diagrams when we have more than two events. But let's look at this example because this example only has two events going on. So it says here, create a sample space for the event of rolling a 6 on a die and flipping a heads on a coin. So this is what we mean by two events. This is event number 1, so we're going to call this event A, and we're going to call this event B. So along this side we have event A going on because we're rolling a 6-sided die, and rolling a B in this side, which is flipping a coin. So what are the possible options we could get? You can see with this construction of a table, we can immediately say that this is going to be H1, H2, H3, H4, H5, H6. So we can get a head 6, heads and a 5, heads and a 4, so on and so forth. Or we could get a tails and 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, tails and a 6. So you can see that this is the sample space for rolling a 6-sided die and flipping a heads on a coin. Now, the more formal way of representing this particular sample space would be to write probability of, let's just say, probability of whatever's, you know what, I'm just going to leave that for now. The proper way of doing this would be to write out the set notation. So this would be H1, that's possible one option, H2, H3, and so on and so forth. You can see that I'm going to eventually finish with T, 6. Okay, so that would be the formal way. However, if you represent this particular form in a test, this should pretty much cover all the possible outcomes you can get. Alright, so just another quick example. Create a sample space for the event of the sum of two dice being rolled. So the sum of two dice. One die would be the event A, and the second die would be event B. So it's asking for the sum. If you remember what the sum means addition. So this is 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7. This will be 7. This will be 7, 7, 7, 6, 6, 6, 5, 5, 4. Obviously you can do the additions if you want, but just to streamline time, I'll fill this in for you. 11 and 12. So now, what I'd like you to do is I'd like you to consider these questions that I've put on the right. And after you've read these questions, I'd like you to pause the video, and I'd like you to actually lock in an answer, and then unpause the video when you have written something down. So what's the probability of rolling a sum of 6? Well, let's have a look at this question now. How many possible options can we get a 6 with? 1, 2, 3, 4, 5. So the number of possible outcomes we could get is the probability of rolling a 6 is equal to 5. But how many possible outcomes can we have? In other words, how many total outcomes can we see here? Well, there's a total of 36. And how do we do that? Well, we can just count up the number of squares that we have. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or we can just say there is 6 times 6, which is 36. So this will be 5 out of 36. Now the question B says rolling a sum less than 4. Well, how many numbers here are less than 4? We've got 1, 2, 3. So in other words, probability of rolling sum less than 4, that's equal to 3 out of 36. Or in other words, that's the same as saying 1 out of 12. Now the next question is, what's the probability of not a 5? So what's the probability that we don't roll a 5? Okay, well, what's the probability that we do roll a 5? 1, 2, 3, 4. So the probability that we roll a 5 is 4 out of 36. So that means the probability that we don't roll a 5 is a complementary event, which means that it is 32 out of 36. And this can be simplified because what's a common number that goes into 32 and 36? The number 4, and that goes 8 times, and this goes 9 times. So the last question is rolling a sum of 2 or 11. The probability of rolling a 2 or 11, well, what's the probability of rolling a 2? There's 1 and 11. There's 3 options there, so probability of rolling 2 or 11, that's the same as saying 3 over 36, which is the same as saying 1 over 12.